Time. It flows forward, second by second, minute by minute. We cannot stop it, and we cannot reverse it. For most of us, time feels like a river carrying us into the future. But what if that river could be crossed, or even outrun? What if we could journey into the future, not by waiting, but by traveling through time itself? The idea of time travel has fascinated humans for centuries. Writers imagined portals, machines, and wormholes that could carry us into tomorrow. But beyond fiction lies science, and science tells us something astonishing. Time travel into the future is not only possible in theory. It has already been observed in small but measurable ways. In this documentary, we will explore how the laws of physics shape our understanding of time, how relativity proves that time can slow down, and how gravity itself can act as a time machine. We will journey into black holes, examine wormholes, and confront paradoxes that challenge the very meaning of reality. This is Time Travel Explained, a story of mystery, science, and discovery, a journey into the future. Before we can travel through time, we must first understand what time is. For much of human history, time was seen as an absolute flow. The ancient Egyptians measured it with sundials, and medieval monks marked it with bells. Time was regular, constant, and unchanging. Isaac Newton believed time ticked uniformly across the universe, like a great cosmic clock. But Albert Einstein changed everything. His theory of relativity revealed that time is not fixed. Time is bound together with space into a single entity, spacetime. Like fabric, space-time can bend, stretch, and twist. Time does not flow the same for everyone. It depends on how fast you move, and how strong the gravity around you is. In other words, time is not a backdrop to the universe. It is part of the stage itself, constantly shifting with the forces of nature. The first doorway into time travel lies in Einstein's special theory of relativity. Imagine you are traveling in a spaceship close to the speed of light. Inside your ship, time feels normal. But compared to someone standing still on Earth, your clock ticks more slowly. This phenomenon is called time dilation. Scientists have tested this with precision atomic clocks. One clock placed on a high-speed jet and flown around the world runs slightly slower than an identical clock on the ground. The difference is tiny, but real. This means that astronauts aboard the International Space Station are technically time travelers. Because they orbit Earth at high speeds, they age just a little less than the people below. It may be only fractions of a second, but it proves the principle. At near light speeds, the effect would be enormous. A trip lasting just a few years for the traveler could mean centuries have passed on Earth. Relativity shows us that moving fast enough lets us journey into the future. Speed is not the only path into the future. Gravity also changes the flow of time. Einstein's general theory of relativity showed that mass bends space-time. The stronger the gravity, the slower time passes. We can observe this on Earth. Precise clocks placed at different altitudes tick at slightly different rates. A clock at sea level, closer to Earth's gravity, runs more slowly than one on a mountain peak. Now imagine being near a black hole, where gravity is unimaginably strong. To an astronaut orbiting near its edge, time would slow almost to a halt. Hours near the black hole could equal centuries in the wider universe. This is not fantasy. It is physics. Gravity itself acts as a time machine, stretching seconds into centuries. To understand the effects of time dilation more clearly, consider the twin paradox. Two identical twins are born on Earth. One remains on the planet, while the other boards a spacecraft and accelerates close to the speed of light. After years of travel, the spacefaring twin returns home. To their surprise, their sibling has aged far more than they have. This thought experiment highlights the strange reality of relativity. Time does not pass equally for everyone. It depends on speed and gravity. The twin paradox may sound like science fiction, but it is rooted in measurable effects proven by experiments with clocks and satellites. It reminds us that time is flexible, and under the right conditions, humans could leap into the future. If relativity allows time dilation, it also hints at more exotic possibilities. One idea is the wormhole. A wormhole is a tunnel through space-time, connecting two distant points. In theory, entering one end could allow instant travel to another place, or even another time. Physicists have studied whether wormholes could exist. The equations of relativity allow them, but keeping one open would require a form of exotic matter, something not yet discovered. For now, wormholes remain speculative, but they show that the universe's laws may contain natural shortcuts, pathways through time and space that challenge imagination. Relativity is not the only science that reshapes our view of time. At the smallest scales, quantum mechanics introduces even stranger possibilities. Particles in the quantum world can exist in multiple states at once. Some theories suggest that quantum effects might allow time loops or even multiple timelines. While most physicists agree that backward time travel creates paradoxes, forward time travel through quantum mechanics is not ruled out. Quantum research has already given us technologies like computers and lasers. Its connection to time remains mysterious, but it could one day reveal deeper truths about reality. The question then becomes, could humans actually build a time machine? The most realistic approach is speed. If we develop spacecraft capable of traveling near the speed of light, astronauts could move into the future. But such technology would require energy far beyond what we can currently generate. Another possibility is using gravity. If humanity ever reached a black hole and learned to orbit safely, we could leap into the future by harnessing time dilation. But black holes are light years away, making this approach impractical for now. For today, the only time travelers we can build are subatomic particles in accelerators. But the path is there. Science has shown us that time travel is possible. Technology is the barrier. Even if we cannot yet build a time machine, time travel continues to fascinate us. Perhaps it is because time defines our existence. We live our lives bound by its flow, and we dream of breaking free. To step into the future is to glimpse what lies ahead, to escape the limits of human life. Time travel also raises profound questions. If the future can be visited, is it already determined? Or do we change it simply by going there? Philosophers, scientists, and storytellers all seek answers. But the fascination remains, driving curiosity and inspiring exploration. Whether or not humans ever travel far into the future, the study of time has already changed the world. Relativity gave us GPS, space exploration, and modern physics. Quantum mechanics gave us electronics, computing, and communications. By chasing the dream of time travel, humanity has developed tools that shape daily life and technologies that define our future. The pursuit of time travel is, in truth, the pursuit of knowledge. Every discovery brings us closer to understanding the universe. So, is time travel into the future possible? The answer is yes. Relativity proves that speed and gravity can slow time. The universe itself provides natural time machines. But for humans, practical time travel remains beyond reach. The energy, technology, and distances required are immense. Still, the dream endures. It inspires science, fuels imagination, and pushes humanity forward. One day, perhaps centuries from now, travelers may return from space to find Earth transformed by time. Until then, we continue to learn, to imagine, and to explore. This is Time Travel Explained. This is the story of our quest to journey into the future. If you enjoyed this exploration, subscribe for more journeys into science, discovery, and the hidden universe.